Hey guys, it's Miss Buck. I think some of you are still having problems understanding how to work these force equals mass times acceleration problems. So even though I put the answer key in there for you, I'm going to go ahead and work it out for you just so you can hear me do that if you need it, okay? All right, so basically what we're supposed to have learned to this point with Newton's second law is that the acceleration on an object, okay, how quickly it's going to speed up or slow down or change direction, depends on two things. It depends on the force that we're putting on the object, and it depends on the mass of the object. And that should kind of make sense. Don't make that overly hard. If I am trying to push a box, then obviously the more force that I put on the box, the more quickly it will accelerate. But if I put the same amount of force on a much more massive box, then obviously it's not going to accelerate as much. All right, so don't make it overly hard. There's three variations that we need when we're looking at the relationship between force and mass and acceleration. If the problem asks us to solve for force, we're going to use this equation. If the problem wants us to solve for acceleration, we'll use this one. And if it wants us to solve for mass, we'll use this one. All right. So the first one says, what is the rate of acceleration? So immediately I know I need this equation. Okay. This is the equation I'll use. Of a 2,500 kilogram truck with a force of 4,200 newtons. Okay, well, I have some information. I have a 2,500 kilogram truck. Now, when you see anything with the word gram in it, this is kilogram. That kg stands for this. But in science, if I see that word in anything, I know that's the mass. And then the problem also says I have 4,200 newtons of force. Remember, force is always going to be measured in a newton. So now I'm ready to just plug these numbers in. So acceleration equals force, that's 4,200 newtons, divided by the mass. And I believe if you put that in your calculator, you get 1.68. Now, this is where it gets a little tricky, guys, okay? I'm solving for acceleration. Look what I have left over as far as my units. I have a newton and I have a kilogram. So I'm going to write it just the way it looks. I have a newton and I have a kilogram. Well, okay, but that is not really what we usually are looking for with acceleration. So there's a little trick here, and that is that 1 newton equals, I know this looks messy, it equals a kilogram meter per second squared. Isn't that weird? Okay, that's just, we can say that. Mathematically, you just have to accept it. Just trust me on it. 1 newton equals a kilogram meter per second squared. So watch what happens. Instead of that n, watch what happens if I put this mess in there on the top. Put that in there for the n. Make sure I've got that so you can see it. And then all of that is divided by that kg on the bottom. And look what happens. That goes away. And my final answer is 1.68. Push this up so you can see it. 1.68 meters per second squared. Okay. So in all of the problems we're going to do in 8th grade, we're going to have your acceleration will always usually be a meters per second squared. This is a distance and this is a time. So this is telling me that every 1 second, the average acceleration on this object, it's going 1.68 meters per second faster, okay? So this is the final answer to number 1, all right? Okay, so I'm going to do number 2 for you on this problem. And number 2 says how much force is needed to accelerate a 64 kilogram skier at a rate of 1.2 meters per second squared. So it's asking me to solve for force. How much force? So I'm just going to go back up here. I need this equation. Force is mass times acceleration. Okay. And in number 2, it says the mass is 64 kilograms. Now, it actually doesn't use the word mass in the problem. I have to see that kg, and I have to know that g is for grams, and that must be the mass. And the acceleration, it does give me, is 1.2 meters per second squared. So I'm going to multiply my two numbers together, and I get 76.8. Look what I get. Kilogram meter per second squared. Now, if you're not a real mathy kid, honestly, I think the thing for you to do is just remember that we're always going to measure force in newtons. We're going to measure force in newtons. And you can just write that down. But look what I have here. For those of you who are kind of mathy, look what I have. A kilogram meter over a second squared. And see, right up here, a kilogram meter per second squared equals a newton. So really, my final answer is measuring, asking for force, and I can just rewrite it and put a newton. All right, I'm going to do one more problem for you because I wanted to do an example of each. We've done an example solving for acceleration. We've done one solving for force, and so we'll do a final one that wants mass, okay? So problem 3 says, what's the mass of an object that requires 45 newtons of force to accelerate at a rate of 5 meters per second squared? So the formula I need, I'm solving for mass. I need to get the force and divide it by the acceleration. And the problem says that I have 45 newtons of force. This is problem number 3. And here's my acceleration, 5 meters per second squared. And I can do this in my head. 45 divided by 5 is 9. Look at all this mess I still have. I still have a newton, and I still have a meter per second squared. 2 ways we can do this. If you are not a mathy person, it is fine. Most of our problems right now, if it's solving for mass, remember I said the G is grams, you can just kind of write kilograms. But these problems will get harder at Dobyns-Bennett, so I'm going to go ahead and remember that a newton is equal to a kilogram meter per second squared. I'm going to divide it by this meter per second squared. That cancels out. And the only thing I'm left is my kilograms. So the final answer is 9 kilograms, okay? All right, so I worked those first 3. I worked one of each, and see if that helps you guys out some. All right.